Okay, in the chapter 4, it's about orthographic writing, and the topics will be view selection, and then alignment of views, orthographic writing steps, basic dimensioning, and then tangency and intersection. For the last meeting, we already discussed about the projection of drawing, and we know that the method is a glassbox method, how to create projection view. For example, front view, right view, left view, top view, and then a bottom view. And today we will continue about the projection view based on the orthographic writing. And then about the view selection. The view selection steps, we can follow this step. At first, orient the object to the best position relative to a glass box. And then the second, select the front view. Remember, you have to select the front view first. And then the third, select the adjacent views. For example, side view, you can select right view or left view. Step 1, orient the object. The object should be placed in its natural position. And then the object should present its features in actual size and shape in orthographic views. For example, you see the two figures in the screen here. The left is the best choice, and the second is not good. So you have to place in natural position. Step 2, select a front view. The object's longest dimension should be presented as a width. For example, this is the figure of car. The first choice for the front view is this one. And the second choice, this is the front view choice in technical drawing. And then another projection view will be like this. This is the top view, and that's the right view. And the second choice, we will get the top view like this, and the right view like this. What is the difference between these two choices? For the first choice, this is with more space compared to the second choice. So the first choice is inappropriate, and the better is the second choice. So this is the example how to select the front view. And then still in step 2, the adjacent views that are projected from the selected front view should appear in its natural position. For example, when you get the projection, you see the top view is not the natural position. Also for the side view. So your selection is not good or inappropriate selection. Just the view that have the fewest number of hidden line. For example, you have the objects in 3D view like this. Then you want to select a front view. For example, you see the arrow here is indicated the front view, and you will get the front view like this. Compared to the second selection, for example, you select this one as a front view. So you will have more hidden line in here. So the first choice is good with the lower hidden line compared to the second choice. And then step number 3, select an adjacent view. Choose the view that have a fewest number of hidden line. You see, this is the 3D view of your object, and this is a front view. Then you will select another view or another projection view. So you should select the fewest number of hidden line. For example, we have two projection view, right and left view. So which one will be the side view, left or right? So based on the suggestion, with the fewest number of hidden line, you should select the right view. So the right view is good selection, and you can eliminate the left view. And then about the top view and bottom view, you see which one is fewest number of hidden line. So from this figure, we can see the top view has a fewest number of hidden line. So you can eliminate the bottom view. So here we can see we have front view, right view, and then top view. This is the example how to select the projection view of your object. And then choose the minimum number of views that can represent the major features of the object. For example, in here, you have 3 projection views here. Is it enough or too many views? So you can choose the minimum number of views. It's depend on the dimension that we need to create in the projection view. For example, this is necessary to indicate the dimension. And then the whole for the top view, hole's location can be spied on the same view. So from the top view, it will be easier to understand the location of the hole. Compared to the another projection, for example here, the position of hole from front view and right view, this is more difficult to interpret the location of the holes. So the top view is necessary. And then choose the views that are suitable to a drawing space. For example, we have the object like this. Then we want to make a projection with the landscape view like this. So this is the front view and top view. This is not enough space for dimensioning. So you can select another projection view. And then you can select another projection view like this. This is better than the first choice. So you can create dimension on the another space. And then for the example, the view selection, for example, we have the 3D view like this. This is a triangle in 3D view. Then, for example, you will select this position as a front view. Then you will draw in the projection like this. It's the same with the width or W here, and for the height here. But we have a D dimension. For example, from the top view. So we have front view and top view here. How about this projection view? If we only have front view and top view, it is describe the size and also the shape. Size is okay, but the shape description is not. Because if you have only front view and top view from your figure here, it will be interpreted to another object. For example, it could be like this. So you need another projection view. For example, you get the right view. So for the 3 views in here, the size is okay, and also the shape description is okay. But is it enough or 2 more projections? For example, we have only 2 projections, top view and right view. So from these 2 projection views, we have know about the size description and shape description. So it means you should be select 2 projection views of top view and right view. And then 1 view drawing. Sometimes you only need 1 view in drawing. This is for flat part having a uniform thickness. For example, this part is created from plate, so it have uniform thickness. So you only need 1 view drawing. For example, when you make a projection, front view, right view, and bottom view, this is the 2 views provide only information of thickness. So only thickness. So you can eliminate another projection view. Then you only need 1 view drawing. And then put the information of thickness. For example, This is when thickness, you have to give the information in your drawing. And then cylindrical shape part. For example, you have a cylinder part in here, and then you will create the projection view. You see, if you have 3 projection views like this is the repeated object. This is unnecessary. And also this one, only the information of diameter, also unnecessary. So on you only one view drawing. As well for this one. This is only one view drawing is needed. And then 2 view drawing. For example, you have a 3D part like this. There exists an identical view. For example, this is the front view of your object. Then you make another projection view, top view and right view. This is the same object. So only repeat the projection view. So for this projection view, you only need 2 views. Top view and right view. And then the third view has no significant contours on the object. For example, we have the 3D view of the object, then you get the front view of the object, and you make a projection of top view and right view like this. The right view is unnecessary. So you only need 2 projection view, front view and top view. And then about this object, this is also only 2 projection view. For example, this one is a front view. Then you try to make a top view and right view. So the right view is not necessary. So you can remove it and you have only 2 views here, front view and top view. And then about the alignment of views. About the projection system. Number 1, first angle system. This is the European country and also adopted for ISO standards or International Organization Standard. And then number 2 is third angle system. This is adopted for Canada, USA, Japan, and Thailand. What is the method of first angle system? You see, when we created the glass block concept on the first quadrant, and you can see from this position, this is the first position on the first quadrant of your glass block concept. Then you put the object in the glass block. Then for the third angle system, put the glass block on the third quadrant and then put the object in the glass block. So you will get different projection position. And for the first angle system, this is the glass block, and then your object put in the glass block. Then you can compare with the third angle system, this is the glassboard, and your objects is in the glassboard. And this is the position to view the front view. And then the object will be projected to the plane. All of this projected in the wall on the plane. And then for the third angle system, you see the position of glassboard. Is in here. Okay, this is the front view between first angle system and third angle system. What is the differences? No difference. Yeah, between angle system and third angle system. Yeah, first angle system and third angle system. For the front view is not difference. And then this is the right view. It's projected to the wall like this. And then for the third angle system, also projected to the wall. Compare between first angle system and third angle system about the right view, also not difference. And then top view is also projected. This one for the first angle system and third angle system. And then what is the differences between these systems? We see we have 3 projection views in here, and then we want to open the glassboard. This is the folding line to see the differences. Here we get the projection of first angle system, and then for the third angle system, also we open it in the folding line here. Okay, after we get this one, we can compare between first angle system and third angle system. Okay, the position of front view is the same, but the different position of top view and right view. So when we see the first angle system, for the top view is on the bottom, but for the third angle system, the top view is on the top. And then from the right view, it's on the left for the first angle system, and for the third angle system, the right view is also on the right side. So here, between first angle system and third angle system, you can see the differences of the position of projection view. And then about the projection symbols, this is for first angle system. We put the object in here, and then the projection on the wall, and then we open it, and we can see the symbol here, this is the first angle system. Also, this is for international standard organization. And then the third angle system, we put the object here and make a projection, and then we get this one. So this is the symbol of the projection system. You have to remember about this one because this is the important thing when you make a technical drawing. And then the suggestion proportion about the dimension of the symbol here. Here the small circle with the D, and then the length is 2.2 D, and then the larger circle is 1.7 D. And then about the orthographic writing steps. Writing step, at first select the necessary views, and then the second lay out the views, and then the third is project the views, and the fourth dimension the views. Number one, select the necessary views. For example, you have the 3D object like this. Which one will be the views? For example, you select this one as a front view, and then top view is from here. Then you go to layout the views in here. For example, this is the dimension. Choose an appropriate scale. For example, 1.1 scale. So you get the projection like this. So at least you need this space. For example, put this one area to the E4 paper. Okay, this is the layout of your figure or projection. Then you can continue to draw the projection views. For example, this one you can continue to create line, and then circle, and then another circle, and then line, and you will get the top views and another view as well. You can continue with line, create line. You can make it a bold line, and then you will get the views like this. Also, you can draw the center line. And then you can do the dimensioning. Transferring the depth dimension, the first direct measurement. For example, you see the dimension of your object in here, and then make another dimension in here, and then you will get the projection. And then the second, use millimeter line. For example, you make a line with 45 degrees, and then continue the horizontal line, and then vertical line, then you will get the projection. But you see this too close, so you can move the 45-degree line. And then from the horizontal and vertical line, then you will get the projection views like this. And then about the basic dimensioning, you have to know about the components of dimension. Number one is extension lines, dimension line, leader line, dimension numbers, and also local nodes. Extension line, this is the extension line from the line that will be dimensioned. And then the dimension line with the arrow is a line that will be put the dimension number. And then leader lines usually used for circle or fillet in here. And then the dimension numbers is a number that indicate the distance or radius or diameter of the object. And then local nodes. For example, you put 10 drill 2 holes. This is the local node. It means this hole have 10 millimeters of diameter, and there are 2 holes in here. And then about the tangencies and intersection in technical drawing. Tangent and intersection, no line is formed when curved surface tangent to a plane surface. For example, you have a radius in here, and then you want to see this is the tangent line between horizontal and also tangent line between vertical and the corner. So no line is formed because this is the tangent line. Line is formed when curved surface intersect a plane surface. For example, you have a curve here that intersect with another line. So you have to create a line in here because this is not a tangent line. And then about this object, we have a tangency line in here. How about this one? For this tangent line and intersection, you have to describe which one is tangency and intersection in your drawing. So the intersection is create line, but for the tangency is not. And then about this one, the line create is not for the tangency, but this is for the intersection. Also this one, this is a plane, so you have to create a limiting line in your projection view. And then about this one, this is the intersection line that you see from the front view and top view. About this one, this is the tangency, and for the another projection, you can create the line. How about the second figure in here? We have a tangencies in here. So there is no line in here because this is a tangency. Also this one, this is a tangent, or tangency. So you do not need to create line. So this is no line in here. And then this one, this is the tangents. Also, this position is tangents. All tangency line is no line in the projection. Okay, this is the assignment 4. Select the projection type. So you have to select the projection type. We have 2 types of projection, first angle and third angle, and then draw the projection symbol, and then draw the figure in top, side, and front, side, and top views. And then your assignment should be uploaded through the Schoology. Okay, any question?